Hello and welcome to Maths with El Profelo. In this video we're doing some elementary number theory and in particular focusing on quadratic residues. Okay, so once again our definition for quadratic residues is that if we have a being an integer and m being a positive integer where a and m are relatively prime, then a is said to be a quadratic residue modulo m if the quadratic congruence x squared is equivalent to a mod m is solvable in the set of positive integers, or in the set of integers, excuse me. Otherwise, a is said to be a quadratic non-residue. All right, so residue would be a possible remainder. Non-residue would not be a possible remainder on division by m. Okay, so let's say that p is an odd prime number. Okay, then there are exactly, right, and actually this should say p is an odd prime number where a is an integer and p does not divide a. I don't know why I left that off there. Okay, right, then there are exactly p minus 1 over 2 incongruent quadratic residues modulo p and an equal number of incongruent quadratic non-residues modulo p. Okay, so actually you don't need this piece for our definition here. I was thinking of a different proposition. Okay, so let us say that we want to use this proposition to find all incongruent quadratic residues and non-residues modulo 17. Okay, so what can we do? All right, well, first, let's understand what we're being asked. Basically, we're being asked that if x squared is equivalent to a mod 17, where x is an integer, what are possible values of a? Right, and those would be our residues. Okay, now we know from proposition 4.3, right, we know from proposition 4.3 that there will be 17 minus 1 all over 2, which will be 8, residues, okay, modulo 17. So here's all we have to do. All we have to do is find out, okay, well, we have 1 squared is equivalent to 1 mod 17. 2 squared is equivalent to 4 mod 17. 3 squared is equivalent to 9 mod 17. And 4 squared is equivalent to 16 mod 17. Right, so 1, 4, 9, and 16 are possible residues, as well as 5 squared, whatever that is, mod 17. 6 squared, whatever that is, mod 17. 7 squared, whatever that is, mod 17. And 8 squared, whatever that is, mod 17. Okay. Well, 5 squared is going to be 25, and that's 8 more than 17. 6 squared is 36, and that is 2 more than 34. 7 squared is 49, and that is 15 more than 34. And 8 squared is 64, and that's 10 more than 54, right? Where, 8 squared is 64, and that should be 13 more, 13 more than 51, right? Because 17 times 3 is 51, so this should be a 13. So therefore, our non-residues are those numbers not included there, and our residues are those numbers that are included, right? So if we have our quadratic non-residues, mod 17, and our quadratic residues, modulo 17. Okay, well, let's do the residues first. What's going to be our set of numbers? Well, we have 1, 2, 4. So that's 1, 2, 4. All right, so that's that one, that one, that one. We also have 8, 9. Okay. And continuing, we have then, let's see here, 13, 15, and 16. Okay. Well, what does that mean our non-residues are? Therefore, the non-residues would be 3, 5, 6, 7, 10, 11, 12, and 14. Okay, so that is how we can find these incongruent quadratic residues and non-residues modulo p, right, where p is a prime number. It is very important that we understand this proposition requires p to be an odd prime number. This has been Maths with El Profe Lo. As always, if you have questions, please do reach out.